Okay, resuming with question 7, this is now part C. Okay, question 7, part C of May, June 2017, variant 1 of paper 4. Now, it says another line is parallel to AB and passes through the point 0,7. Okay, now, what you need to know here is the line AB. Well, this was the line AB. The equation of the line through A and B was y equals minus 2x plus 2. So that means the gradient of the line AB, okay, the gradient of the line AB, MAB, the gradient of the line AB is equal to minus 2, as we discovered in part B of this question. Now, when two lines are parallel, they have the same gradient. So the gradient that we need is going to be the same as the gradient of the line AB, which is minus 2. And they told us it passes through the point 0,7. Okay, so it tells us to write down the equation of this line, which gives us an indication that there's no calculation involved, okay, which should give you an idea of what to do, because the equation of the straight line is y equals mx plus c. Now, c is the y-intercept, and as we discussed before, okay, in some of the other videos, the y-intercept is a place where the line cuts through the y-axis. Okay, so this line has a gradient of minus 2, and it cuts through the y-axis at the point 0,7, because it passes through the y-axis at 0,7. 0,7 is a point on the y-axis. This line passes through the point, so this line must have passed through 7 on the y-axis, and it has a gradient of 2, so it's going to be somewhat steeper than that, no problem. So that is the y-intercept. So we don't have to actually do any calculations in this question. We can just write down the answer as y equals minus 2x plus 7, okay, because we know that the gradient is minus 2, which we discovered in part B, and the y-intercept is 7 because the point they gave us was 0,7. If they gave us a point like 3,7, for example, I can't say the 7 is the y-intercept because 3,7 is not on the y-axis. Okay, so I can't use that and directly write down what c is. Okay, I'd have to use that point in the formula and find what c is going to be. So if they give us any coordinate with the first part of the coordinate, the x part as 0, that means that lies on the y-axis. So y is equal to minus 2x plus 7 is the equation that is parallel to AB and passes with the point 0,7. Now part D says find the equation of the line which is perpendicular to AB. Now what we should know is that when two lines are perpendicular, their gradients are called negative reciprocals of each other. Okay, so the gradient of the line AB is equal to minus 2. So the gradient of the line that we need this time in part D, the gradient of the line of part D, is equal to the negative reciprocal. Now, what does that mean? Well, let's think of this as a fraction. As a fraction, this would be minus 2 over 1. The negative reciprocal, negative means you change its sign. So it's not going to be positive anymore. It's going to be, sorry, it's not going to be negative anymore. It's going to be positive. If it was negative, you have to change its sign. And the second thing, it's going to be the reciprocal, means you have to flip it upside down. The numerator and the denominator switch places. So you change the sign, so it's no longer negative, and you make the numerator and the denominator switch places. So the gradient of the line that we need is a half. One of the things you realize about gradients of lines that are perpendicular is that the product will always be negative 1. You can see if we multiply negative 2 by positive a half, you'll end up with negative 1. Okay, so two lines which are perpendicular, their gradients, the products of their gradients will always be negative 1. But a simple way to deal with it is when you have a line and you know the gradient of the line is something, the gradient of the line that's perpendicular to the line will be its negative reciprocal. So you change its sign and you make the denominator and numerator switch places. If it's a whole number, you just write it over 1 first and then proceed. So this is the gradient of the line that we need, and they've told us that it passes through the point 1,5. Okay, now this time, okay, I can't just use the 5 as my y-intercept because this is not on the y-axis. 1,5 is somewhere over here, somewhere up here. It's not the y-axis. Okay, so the gradient of this line is going to be a half, so it's going to look something like this. So it's going to go somewhere through the y-axis under 5, we know that. But we're going to calculate exactly what it is. And they've told us to give the answer in this particular form. So I'm going to show you two different ways of doing this, okay, from the two different ways that we learned about how to write down the equation of a straight line. Now, y equals mx plus c is what normally people like to use. Okay, most people, students in IU, normally use this. So I'll use this first. So remember, this is the gradient of the line that we need. So we've got this information here. This is the gradient and the point that we're going to use. So the y coordinate is 5. The gradient is a half. The x coordinate is 1. And we have to find what c is. So basically, it's going to be 5 minus a half equals c. So 5 minus a half is 4.5. Okay, so c is equal to 4.5. I'm going to write that as an improper fraction. That's going to be 8 plus 1, 9 over 2. Okay, so c is 9 over 2, so we can say y equals a half x plus 9 over 2. And as we said, it's going to cross somewhere under 5, which is what that is. Okay, so now they don't want it in this form. They want it in the form ax plus by plus c equals 0, where a, b, and c are integers. So they want all of these numbers to be integers. So we got to multiply both sides of this equation by 2. Okay, we multiply both sides of this equation by 2. Why? To get rid of the fraction. We have an equation, you want to get rid of the fraction, you multiply both sides by the LCM of the denominator. So if I multiply both sides of this equation by 2, I'll get 2y is equal to 2 times a half is x, and 2 times 9 over 2 is 9. And furthermore, they want it with everything on one side. Okay, so what we can do is, we can write it as, I would prefer to write it with the x positive, so I'll say 0 is equal to x minus 2y plus 9. So you end up with x minus 2y plus 9 equals 0. If you wanted to, you could also write it, I suppose, as 2y minus x minus 9 equals 0. That's still following the same format. Okay, but it's better, I think, to keep the x term as a positive. It looks a bit better. So that's the answer to this question. Now I'm going to show you how to answer the same question using the other formula that we learned, which I think in this particular type of question, when they ask us to express an answer in this form, and a gradient is a fraction, is probably easier to use. But there's no problem if you don't use it. You can do it the other way. Okay, but the other formula we learned is y minus y1 equals m times x minus x1. Now m is the gradient as before, which is a half, and x1 and y1 are the coordinates of the point that we've given. So x1 is 5, and y1 is, so x1 is 1, and y1 is 5. So you have y minus 5 equals a half times 1, so x minus 1. Okay, so x1 is where the coordinate of 1 goes, and y1 is where the coordinate of y goes. So now, the good thing about this is you have a fraction here, you can just multiply both sides by the denominator straight away. So I'll multiply both sides by 2. If I multiply the left side by 2, I'll have 2y minus 10. Don't forget to multiply both of them by the 2 equals, and this side I'll have 2. If I multiply by 2, the half will be cancelled out. If I multiply 2 on this side, the half cancels out, right? So multiply by that side, I got 2y minus 10. This side, 2 times a half cancels out, so you're left with on this side x minus 1. Okay, so if we now bring everything to the side where x is, you've got x minus 2y, got minus 1 plus 10, which is going to be plus 9. So you end up with the same answer, x minus 2y plus 9 equals 0. Okay, so that concludes this question for you. So hopefully you understood that, and if there's any problem, please let me know. Thank you very much.